Okay, second video of the day. This is going to help you complete your lab with the picture section and the shape section. You should already be done with the dot diagram and the name. Now, what we're talking about here is how we determine the shapes. You created all these different shapes right here. When you drew the dot diagrams, those are just 2D. They're kind of hard to imagine. The shapes themselves have a name, and being able to create these shapes is based on a very specific theory on how we think covalent compounds appear. So we're going to learn the names of the different shapes you already created, and they are all really fall under 4 names. Vsepr is the theory behind each of these names. That theory stands for valence, shell, electron, pairs, repel. Remember what I said in the last video, whenever they come together in covalent compounds, all electrons have to be in pairs. Then those pairs repel each other. That's how you end up with all of these like an equal distance apart. Rather than everything ending up on one side, these electrons, because they're all like charges, you've probably heard this before with different things, like things that are alike repel. So that's the same with electrons. They're all negative charges, so they repel each other. So that's valence, shell, electrons, electron pairs repel through Vsepr. Now, these are our 4 different shapes. You can only see a couple of them right now. Whenever I scroll down momentarily or scroll up, you'll be able to see the last one a little bit better. But let me just move this. I think that'll make it easier. Sorry about that. There we go. Boom. Now you can see all 4 until I scroll up and screw it up again. Boom. Now you can see all 4. Go Team Wilson. Okay, these are our 4 shapes, and I'm going to show you how each of these form what they're each called. This right here is called linear. Linear are basically perfectly symmetrical on either side. So symmetrical, oh my gosh, there we go, on either side. So they balance each other out perfectly so they can come out in a straight line. You see this? One side you have 2 electrons and an atom, 2 electrons and an atom. Perfectly symmetrical on both sides, therefore they will repel each other perfectly and come out in a perfect 180-degree angle and a linear molecule. So this would be an example of a linear molecule. Our next one, I'm going to go through and then we'll go back and do examples. Bent. This right here is a bent shape. A bent molecule results from having 2 electron pairs or 2 electron bonds. Those are right here. Here's one bond, here's a second bond, and 2 lone pairs. Now in the last video we talked about lone pairs. This would be an example of a lone pair right here. You know, there's 2 electrons up here, 2 electrons right here, and they are not bonded with anything. So those are lone pairs. These are electron bonds, 1 electron bond, 2 electron bonds, and 2 lone pairs. And what happens is because they repel, lone pairs actually repel more. They repel greater. So the lone pairs actually force these down here. So that's why it comes out looking bent. I drew these on here so you could see it, but typically you wouldn't even draw these. You would just see this, and you know it's bent because there's some lone pairs up here who are really forcing these electron bonds downward because they're really repelling them hardcore because they don't like them because they're lonely and they're happy, and so the lonely ones don't want to be next to the happy ones, so they're forcing them away so they can be sad by themselves. So lone pairs really force these down, which causes this bent shape. Our next one is right here. This one is the one I'm going to. This is called trigonal pyramidal. Trigonal pyramidal. You can say that however you want. You may say I'm saying it wrong. Whatever. You can say it however you want. But trigonal pyramidal. This results from having 3 electron bonds and 1 lone pair. So 3 electron bonds and 1 lone pair. The lone pair here, that's kind of, can't see that. I'm going to bold that. Okay, the 1 lone pair here is represented by this yellow. So that's the lone pair, just like on yours, like these right here are all lone pairs. Lone pair, lone pair, lone pair, and then this is bonded. So this is the lone pair, and then you have your 3 bonds. 1, 2, 3. So sharing, 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 lonely. You can see again, the lonely electrons are forcing the ones sharing to get further away from them because they don't like them. This is the example of that right here. The lone pair is forcing these ones that are sharing the furthest away because the lone pair has more power and doesn't want to be around the happy sharing electrons because it's lonely and sad. So let's take a moment of silence for the lonely one. Okay, sorry, it's been a long day. So lone pair forces the shared electrons further away, and trigonal pyramidal forms when there's 3 electron bonds and 1 lone pair. Our last one is tetrahedral. Tetrahedral. Tetrahedral, this forms when we have 4 electron bonds. 0 lone pairs. I should put that. 0 lone pairs. Everyone in tetrahedral is happy, because being happy is important. So tetrahedral is happy because there's 4 electron bonds. Uno, dos, tres, cuatro. Spanish again. I know I'm impressing some of you. If you ever want Spanish tutoring, it would probably help. 4 bonds right here. 0 lone pairs, so it's happy. So you can compare those. Linear, 2 bonds, and they're symmetrical on either side. Bent is 2 electron bonds and 2 lone pairs. Trigonal pyramidal is 3 electron bonds and 1 lone pair, and then tetrahedral is 4 electron bonds and 0 lone pairs. So what I want you to do, you can see on there, you need to go back through. You'll draw your pictures, which if you didn't already do, you're basically trying to draw something like this. It's kind of tough. But you have the examples on here you can freeze frame and look at as well. A little bit easier of a way to draw your different linear, bent, trigonal, pyramidal, and tetrahedral. And then you're naming the shape. So you would look at this, be like, oh, we have 4 electron pairs. No one is lonely here. So if you're lonely, maybe hang out with this one, and this will keep you company because these are all happy because they're all sharing electrons. This would be tetrahedral. That's the only answer I'm going to give you. I could have broke my whole computer. Tetrahedral. And I'm rambling because that's what I do. So your examples come on your lab. If you have questions, ask, but refer to these shapes, refer to the shapes on your screen, and you should be able to determine if this is linear, bent, trigonal, pyramidal, or tetrahedral. Look at it. Look what it looks like. Linear. Okay. When you are finished, let me know.